Okay, welcome to the first video on Unit 9, the periodic table. So I'd just like to say right now, Unit 9, this is Unit 9 in your syllabus. It isn't Unit 9 in your textbook. In your textbook, it's Unit 12. It's Unit 12 and it starts on page 152. So all of Unit 12 is basically covering Unit 9 in your syllabus. So let's look at your syllabus right now and see what we're going to cover today. So today, like I said, Unit 9 in your syllabus, the periodic table. What we're going to talk about is we're going to talk about, what is the periodic table, and how to characterize, groups, periods, and how the periodic table is arranged. Then we're going to talk about, some basic trends today. So a change from metallic to non-metallic character across the period. And then how this relates to, melting point, boiling point, amount of electrons, what similarities elements have in the same group, what similarities do they have across the period. So that's what we're going to be trying to describe right now today. So our entire lesson is going to be based almost entirely off of this, right off of the periodic table. So let's start. Basically, this periodic table actually tells us, but most periodic tables don't. Vertical columns right here, we call them as being groups. And one important thing to kind of state, there's a difference between groups and main groups. So main groups is right here, is group 1, group 2, and 13 to 18. So this is what we're studying right now in IGCSE Chemistry. We're studying main group chemistry, 1, 2, 13 to 18. And that's why we call this group 3 in IGCSE Chemistry. It's because it's a main group 3, but it's actually group 13. So if we take out, those transition metals, which are metals that we don't necessarily need to know much about in this class. You'll do that more in IB chemistry next year. So, but we take those out, and then we're stuck with only the main group elements. So vertical columns are called groups, and horizontal rows are called periods. So this is the first period, period 1, period 2, period 3. So if we were to look at, let's say aluminium, we'd say aluminium is group 3, period 3. If we were to look at astatine right here, or arsenic right here, astatine, arsenic right here, astatine's down here, AT, arsenic, we'd say it's in group period 4, go across, group 5, period 4, group 5. So that's the first thing that we have to cover, is that vertical columns are called groups, and horizontal rows are called periods. Okay, so we have to look at, what similarity do groups have? So let's look at group 1 right here. We've got helium, lithium, sodium, potassium. That's all we'll do. We'll do helium, lithium, sodium, and potassium. So let's look at the similarity between this. So let's draw these out. So H has 1 proton, so it's got 1 electron. So if we were to draw that structure, it looks just like this. Lithium, sodium. So hopefully you've covered this already in another unit. If not, we're going to describe what this means right away. Lithium and potassium. Okay, so let's draw out these atoms. So helium, like we said, or hydrogen, like we said, has 1 valence electron. Lithium, though, remember our periods, each period is how many layers, basically, how many layers the atom has. So if you're in period 1, so period 1 is 1 layer. Period 2 is 2 layers, etc. So 1 layer, 2 layers, 3 layers, 4 layers. So that's our principal quantum number. So, but we can just kind of think about them and how many different shells does each atom have. So lithium here has 2. The first shell has 2 electrons. So we've got 1 electron here and 1 electron here. And the second shell only has 1 electron. It's at the start of the period, 1. Let's look at sodium. It has 1, 2, same thing as lithium. It's down here. Then it's got 1, 2, 3, 4, 5, 6, 7, 8 in the second layer. So 1, 2, 3, 4, 5, 6, 7, 8, and 1 in the third layer. Let's look at potassium. It's got 2 in the first layer, 8 in the second layer, 8 in the third layer, and 1 in the fourth layer. So we've got 2, 1 or 2, 8, 8, 1. So we can see, the similarity between these 3 atoms is that all of the atoms have the same number of valence electrons. And remember, valence electrons means the electrons in the outer shell. So they all have the same amount of valence electrons. You see 1 here in the outer shell, 1 here in the outer shell, 1 here in the outer shell, and 1 here in the outer shell. So we've got the same amount of valence electrons. And remember, like we said in, I believe it was Unit 2, valence electrons are related to the chemical reactivity. So since they have the same amount of valence electrons, what we need to know is they have similar chemical properties. So similar reactivity. And we're going to study these a little bit more in depth. The next part of this unit is just studying group 1 elements. So okay, let's look at the periodic table. So group 1 right here has 1 valence electron. Group 2 has 2 valence electrons. Group 3 has 3 valence electrons, and so on. Group 4, 4, group 5, 5, 6, 7, and 8. So our group, what the group is, tells us how many valence electrons we have in our outer shell, and it also tells us that these elements have similar reactivity. Okay, so let's go down just a little bit. So they've got similar reactivity. But one thing for group 1, like we said, right? Metals like to give away electrons. And for group 7, group 7, nonmetals typically want to receive electrons. So we're going to see, this is going to be our first important trend for group 1 and for group 2. So let's look at group 1, right? So we've got this electron right here, this little guy. That's what we're talking about. So we've got those electrons right there. And we have to think, right, the core is positively charged for all of these. But the thing is that, the proximity of this electron to the positively charged core is a lot closer. And as we get further and further away, right, this electron barely has any interaction with the nucleus. He's got a very limited reaction with the nucleus. So potassium here likes to, if this electron disappears, if he gives it away, this potassium, the center nucleus isn't really going to care. It's not going to feel that it's losing this one that's so far away, right? You can imagine, the further you get away, the less attraction it feels towards the nucleus. So since it's further away, it likes to give it away more. And since it likes to give away electrons more, we say that it's more reactive as we move down group 1. So more reactive as we move down group 1. But now let's look at our nonmetals. So we're only going to compare 3. Let's compare fluorine, chlorine, and bromine. So fluorine, chlorine, and bromine. So fluorine's got 2 layers, chlorine's got 3, bromine's got 4. So 2, 3, and 4. And remember, like we said, nonmetals like to receive electrons. They like to take electrons. So they take electrons. But now this is a good point. Let's look at this. Let's fill this up a little bit. That's 2. And this is supposed to be 7. 1, 2, 3, 4, 5. There we go. So this is 2, 8, and 7. 3, 4, 6, 7. And this is 2, 8, 8, and 7. So now we have to see, what should we think with reactivity, right? Nonmetals like to take electrons. So to take electrons, the electrons need to feel attracted to this positive core. So on that same note that we just said, right, as we're further away, electrons care less about the core, right? If this one's to take an electron, this electron is super far from the core. He's not going to feel really wanted by the nucleus. And we put another electron here. He's closer, so he's going to feel a little bit more wanted. And we put another one here, and he's going to feel really wanted by the nucleus. He's going to feel really attracted. So you can see that the electrons that they're receiving are more and more attracted as we go up the group. So it's the opposite. Metals become more reactive as we move down the group. And in group 7, it's more reactive as we move up the group. So that's our first important trend for group 7 and our first important trend for group 1. Okay, and that's what we're going to cover for today. I will make another video soon and we'll continue on with this unit. Thank you.